So I'm going to go ahead and do a couple announcements, and we'll get started. This whole call is pretty much going to be dedicated to the Colorado Springs 20-to-1 scale model replication. Today is January 20th, 2024. I'm calling in from freezing cold Spokane, Washington. Back in 2019, Eric Dollar did a presentation on the Colorado Springs 20-to-1 scale model replica. He basically drew up the engineering blueprints for the that scale model replica, and Bruce Gavin over on the East Coast built it and had it sent right to the conference where we demoed it, and Eric did a presentation on that. I'm just going to show a couple links here that are relevant to the Colorado Springs presentation and the topic of this call. Let me do a screen sharing here, and just give me a second. Okay, can everybody see the website up here, like Eric's website?
Yep.
That's going up. Okay. Yep. So EPD Laboratories, Inc. is a 501c3 nonprofit corporation, and it's based out of Nevada, and it's run solely on your donations, which makes a lot of these projects possible. Eric's website is ericpdollar.com, or I should say that is actually the official nonprofit website. And in the main menu bar, there's a donate link here. And if you scroll down, you can donate either by PayPal. You can do a single donation or like a recurring donation. And down below that, if you want to send checks or money orders, there's an address here in Spokane where that comes to me. I just endorse the checks and then send them back down to the bank in Nevada. And this is pretty much what supports probably 90% plus of all the EPD activities. That includes building rent, utilities, insurance, parts for projects, transportation, and food and lodging for people who can come to town and kind of help when we have different get-togethers down there to kind of further these projects. Griffin is also kind enough to have kind of kept Eric's Dollar up to date. If you go to the homepage and scroll down, you can see a lot of the different things relating to a lot of the projects involved with EPD Labs. Another website I want to show real quick is, let's see, before I do that, on emediapress.com, this has most of the presentations, well, it has all the presentations from all the conferences. Everything on eMedia Press is not from the conference. There's some books and other non-conference related presentations. Those are all here right in emediapress.com. You can click on blog. There's quite a few blog posts where I try to keep as much updated as possible. And if you want to search for any products like from Adrian or Eric or Griffin or anybody, you can just type their name in here. It's pretty good search. It'll come up with whatever relevant presentations and everything. Right here on, let's see, I thought there was one other link right here. Okay, on emediapress.com, there's this long link here to Colorado Springs. But if you go to emediapress.com and if you click in this products link, and if you just type in the word Colorado, hit return, it'll bring up this presentation right here. So this is a presentation that Eric gave in 2019 at the Hayden Eagles Lodge in Idaho. That was 2019, so that was roughly about the 7th or so conference that we've had since 2012, since we've been doing these. Now, on this particular page, you can get this presentation. And if you scroll down, here's a YouTube video that has, this is a brief excerpt of some of the actual demonstrations, the different interesting plasma formations, rotating Tesla brush, some of these tentacle type rare plasma discharges, some of the flame speaker demo. The radio gets stronger once this is tied into the ground at the same frequency. Eric can kind of go into all that. And then down below that, these are some bullet points of what Eric covers in that demo. And then there's an excerpt from the presentation, which is kind of like a preview, so you can kind of get an idea of what's in that presentation. And then if you scroll down even more, this video right here is a YouTube video, and this is essentially part 2 to the Colorado Springs presentation given in 2019. Last year at the 12th Annual Energy Science and Technology Conference, Eric and Adrian stayed quite a bit after the conference, and towards the middle to the end of July. This was recorded at my shop here in Spokane, Washington. You can see one of the coil transformers back here in the background, and there's another one over here a little bit out of view. This presentation is about maybe hour and a half, something like that. And Eric and Adrian both are taking various measurements. They're doing different experiments, including some pretty phenomenal and astounding flame speaker demos that most people have never heard. They've taken it to the next level. And so this is all revealing. What's that? If somebody is unmuted, can you please mute yourself out?
Yeah, we're on the air now, so I got to get back to it.
Oh, that's you, Eric. Okay. So anyway, this is a free viewing right here. And so after the call, I would highly recommend, if you haven't seen the presentation, get a copy of the presentation from 2019, go through and watch this free presentation, which is part 2 that was conducted by Eric and Adrian at my shop last July. And then recently on energeticforum.com, this forum has been around since 2007. Eric has been active since about 2012 on this forum. 2011, maybe even actually longer than that, several years before our first conference, maybe even back to about 2008 or something. And if you scroll down in the most recent discussions, there is a thread called Colorado Springs 20-to-1 replication. And if you click on that and you scroll down, I have a link here in post number 1 to the presentation from 2019. The second one is a repeat here of this YouTube video of the part 2. Part 3 is the intro, is the invite to the Zoom call. And this call is being recorded. And once this call is kicked out into a YouTube video, I'm going to embed that right here. So you have the presentation, that part 2, and then the Zoom call. And then this thread is going to be for any kind of discussion. If you're interested in replicating this at various scales, if you want support, or you want to get into more discussion about this particular project, you can come and post it here. Before this call, Eric, in about 15 plus years that Eric has been active in this forum with other people posting for him. Today, he did his first post ever in all those years, logged in and did this little test post. So he knows how to come in here and make comments. And so he's going to be keeping an eye on this. So after the Zoom call, whatever's not covered in here, as far as whatever Eric and Adrian are going to go into, and any questions, this is where the follow-up discussion and conversation is going to go. So let me get out of the screen share here. We can go ahead and get started. And let me undo this.
Is Justin on?
Is what?
Is Justin on?
He is, yes.
Yep, I'm here.
Ernst has been trying to get a hold of you to figure out how to log in.
I've got no messages from him, but I'll mute out my mic and give him a call.
Okay.
Okay, so let's see. Let's find where Eric's video is, and let me get him front and center here with Adrian. Okay, here he is. Add pin. There's Adrian right here. Okay, can everybody see all 3 of us right now? Eric and Adrian? It's all good. Okay, so how do you want to start this, Adrian? Should Eric maybe give a little 5-minute synopsis of his presentation? And
yeah,
then
I think so. We have we have about 30 to 40 slides to show from the extended experiment where Eric and I will talk about it. Eric, did you want to make any opening comments? Or discuss anything first of all?
Well, I got to get warmed up, so you better warm me up.
All right, I'll get you warmed up then. So I suggest probably, Aaron, is that I do a screen share, and then we just start our way through.
Let's see, security. Okay, let me make sure. Okay, you should have the option now to do the screen share.
Okay. Do you see that?
It's a black screen, but it shows. Yeah, here it comes.
Let me know, Aaron, when you can see that.
Yeah, it looks fine.
Okay, good. Okay, so I will get started by just explaining what we were doing, what the apparatus was, and all of those things, and then we'll move on step by step from there. So, as Aaron said, this took place after the 12th annual ESTC conference last year in Spokane. Eric and I both stayed on for some 2-3 weeks after, and we had quite a lot of experiments to do, and the Colorado Springs was always one that we wanted to do based on the work that we'd done previously in the year, which had a lot to do with the modulator bay and the power supply for the RF bay, and also the what we called the hybrid. So we actually demonstrated this also at the ESTC in 2023. We used the hybrid system in the conference to actually do flame speaker and golden ratio discharge and other type of modulated discharges. And this was, if you like, the most advanced experiment that we did was the follow-up, the Colorado Springs extended step 2 or experiment 2. And we did a whole range of things. So if I just explain what I mean by the hybrid, so we start to understand the apparatus involved. So we can see there the coils. So we have the red and the green Colorado Springs coils. The red one in the center there is connected directly to the generator. And then we have its reciprocal coil along a single wire extension. It's about a 3-meter single wire extension between the two, and with various tuning units and other power supplies. And Eric is sitting in front of the RF modular bay there, and we're going to go and have a look at that in more detail as well. So before I jump into any more detail with that, I know Bruce is on the call. Bruce, you actually built and designed these coils, the red and the green coil. Is there anything that you would like to first of all say about the design and construction of the coils?
Well, no, except they were built, as 1/20th scale to the Colorado Springs coils that Tesla built in 1899, and it was a very interesting project working with Eric on it. And I was looking over my lab notes that I wrote up while I was building them in 2019, and recently that was, and it was intriguing to go back over the process that it went through, because the testing that was done, the measuring of the 1 unit green against red, and finding how precise they were actually built. We were able to get very, very close resonances with the extra coil systems within a couple of kilohertz, and the Q factors mostly with the extra coil and the mast assemblies were incredibly close. So for experimental purposes, it was a good baseline, I think, to build on and advance as you guys have done. But I'll leave it at that for now. Thanks.
Okay, and the goal was basically to replicate the original Tesla Colorado Springs setup and experiment and sort of explore what he was doing, right?
Indeed.
Yeah.
Bruce, do please jump in as we progress if there are things that you would like to add, or there are details that you know that we don't know.
Well, I'll point out that great pains were gone through to get everything to turn out to be exactly a scale of what was in Colorado Springs, the magnification factor, the frequency, all of those type of things. And it really worked out good. Everything was like within 1%, which was quite satisfying. So these really are true replications in almost any way. And basically, they can operate just like the Colorado Springs unit, but at a reduced power level.
Eric, just spend a minute sharing with us. How did you go about doing the 1/20th scaling? How do you go about doing that with a system like this? Because it's not just all linear. Huh?
Well, actually, most of it's linear scaling, except when you come to the skin effect and conductor, and then all of a sudden that becomes a square root. And so basically, you can't keep scaling it because the conductor size is not a linear function. It's a square root function. So the conductors start getting closer and closer together. And when you get deeper than 1/20th, then they start to touch and it's not practical. Mm-hmm. So that was basically the limitation. And then, of course, the capacitance and inductance in themselves are nonlinear functions, but basically the whole thing does scale in proportion to lineal dimensions. So what the inductance is distorted nonlinearly on one side of the equation, the capacitance is the other side, so they always cancel out. But conductor diameter versus spacing does not scale. So this took it to the limit of how far it could be scaled.
Mm-hmm. And did you know the target frequency, center frequency that you were working towards, or did you wait and see how that worked out?
It was the frequency, because everything is based on lineal dimensions. The wavelength is completely scalable, so the frequency turned out to be 20 times, because it's inverse, 20 times the frequency at Colorado Springs, which ended up somewhere above 900 kilocycles in the broadcast band, and the thing was virtually right on. So that was quite satisfying.
Good. Okay. I will then proceed further. Just also to add, at the 2019, in the first experiment, after the initial demonstrations, we also did some extended demonstrations there as well, where we actually coupled up an MWO generator and did some additional experimentation. We actually did some rewinding on the secondary coil to make sure with the increased voltage that we were not going to get any arc over. And that's also, then we had to reciprocally do that with the green coil before we started this extended experiment that we did last year, so that both coils were again rewound and matched in terms of their secondary coil characteristics. They don't arc over, so we didn't get any burnouts with the increased voltages that we were using to drive them, and also they were still properly tuned and matched with each other. So I'm going to go through what we have here, because there's quite a lot in the picture, and we need to make sure that we understand what each of the things that we have here before we proceed into the experiment. So this is the red coil here on the table, on the bench, and next to that we have this generator. This was the GU5B power oscillator. It formed part of the hybrid unit. So the hybrid was a combination of the power oscillator generator and the RF power supply, Eric's RF power supply, and the audio modulator bay. So we called that the hybrid because it was a combination of some different technologies, but we realized that we could put them all together and then we could do a range of different experiments. So we ended up, I had the GU5B power oscillator there for the demonstration that I was doing on the golden ratio discharge at the 2023 ESTC. And I also had the power supply. You can see the left here, just in front of Eric. That's the microwave oven transformer power supply, the level shifted of supply that I was using for that demonstration with some modification that we made after the ESTC. So we had a number of different power supply arrangements, and that was quite important because the experiments, the different generators yield different results in the experiments. And we're going to go through those, and we're going to go why those power supplies produce different results as we go along. So it's a single GU5B. This is a Russian triode. It's a particularly good grounded grid tube. As Eric said, it readily wants to oscillate. You don't have to work hard to make this tube oscillate. It wants to oscillate. So it makes a very good power oscillator, and it is also capable of operating quite well outside of its nominal characteristics, which is a great advantage here. It's a very robust tube. It's readily available on places like eBay for around about $100. And also there are some specialist parts that you can get around the world. Hackasys identified somebody that can actually make the tube mount for these, and we ordered those. Those are quite rare things, but they are manufactured new now, so that also makes for a proper build system. So the GU5B is nominally a 5 kilovolt anode. It's rated at about 3 kilowatts maximum anode dissipation. With the kinds of systems that Eric sets up, we're obviously able to drive it considerably harder than that as well. And also it can tolerate burst voltages up to, I've had it up to about 9 to 10 kilovolts on the anode in short duty cycles. So it's capable of pushing packing quite a big punch into your primary system. If you look in between, so here is the final power oscillator. In between there, we have a matching unit. So that's a 1,000 picofarad vacuum variable capacitor. It's a KP14, so also Russian military capacitor, and it has a parallel. This capacitor you see sticking up on top, it has a parallel capacitor as well added onto the vacuum, just to increase the range and lower the frequency slightly that it's working with. That is low inductively connected directly to the 2-turn primary. Let's see if we zoom in. It's not very good resolution at this zoom level, but you can see there's a 2-turn primary. So 20 turns nominally on the secondary, 2-turn primary, and about 100 turns. 100 turns on the extra coil, I believe. So to the left of the generator, that's the GU5B generator here. This is the level shifted AC modulated power supply that I used for the golden ratio discharge. And then behind Eric, we have the other 2 power supplies, which we're going to go into a little bit more detail now. So if I move, yes, that's it. If I move to the next, okay, so here's a little bit more of a close-up of the red coil. We can see the matching unit in between. We get a better view of the GU5B here. And there is a out of sight here behind the red coil. There is a grid feedback coil. So we are using this as a Class C, nominally a Class C Armstrong oscillator. There is a pickup coil just behind where I've got the mouse here, just below the height of the secondary coil. And that feeds back, that's a positive feedback loop back to the tube, which allows it to oscillate. And then this yellow wire is the single wire coming from the bottom end of the secondary coil. So this coil here is a secondary coil with its guard ring around the top, and that coil extends reciprocally over to the green coil, and they are positioned about 3 meters away from each other. Inside, you can see the extra coil and then the elevation up the center to the top load. And here we have the green coil. Again, it's reciprocal. It also has the same matching unit vacuum variable capacitor, KP14, with a shunt capacitor, connected in the same way, double turn, in a reciprocal arrangement. So it forms a cavity. We have a single wire cavity going between the two secondary coils, between the red and the green coils. Here's a nice bit of close-up shot. Now, Eric, you spent some considerable time working on the tuning of these two coils between the two, trying to get the optimum impedance and match across that single wire of the cavity. Can you share us a bit more about that process and what's important there?
Yeah, it was absolute hell.
I remember you saying at the time.
Yeah. So fortunately, I had a real oscillator, not some digital piece of junk. I had something with the knob on it, which was essential. And then, unfortunately, I don't know how widespread this is, but one of the reasons why I do these presentations is so that the end result, I have my own recorded document of what's going on, which makes it easier than losing notes and scrap pieces of paper and all that kind of stuff. Well, Digital decided to edit out all of the 1/20th values, because this is how Digital has fun with us. We call it artificial malevolence. So I did not know what primary capacitor right off, so the 1,000 picofarad variables would not tune this thing anywhere near their operating frequency. So I had ordered some bypass capacitors earlier, which is that one sticking up above the vacuum variable capacitor, which turned out to be way too big, and they were the wrong thing. On eBay, they looked like they were about the size of a quarter, and they turned out being some kind of 10-pound bulk capacitor with quite a kilovolt ampere reactive rating. So I decided to buffer the variable, and I managed to pull the frequency down just within range to the higher oscillating mode of the coil, which is not the right frequency for this operation. It's an odd function frequency, and in order to operate this thing as a transmit coil to a receive coil, it's got to be an even frequency function. So basically, it was not possible to transfer energy from one coil to the other like what's done in the presentation, but it did afford enough of a counterpoise to facilitate the demonstration we wanted to do, which was not transmission so much as the flame speaker and plasma flame and what have you, and it turned out to be quite effective for that. It took me almost a week to battle this out, of struggling with the coupling and trying to get the oscillator to work with the coil, and it was, I about gave up, but because I couldn't hit any frequency because the vacuum variable just didn't have enough capacitor. But if I get the thing to a certain point, it would almost go there, and then I remembered that I have these buffer capacitors, and that saved the day. Otherwise, it wouldn't have been able to show anything. So these are the struggles you go through with this experimental stuff.
This experimental work is always a labor of love.
Yeah, it's not always a labor of love.
Yes. Yeah, there are sometimes other words for that too.
Yeah, but at any rate, the end result is gratifying.
So just before I go on, actually, I'm going to go back to where we see the two. So we need to consider a moment, first of all, the modes of resonance that we are actually utilizing in this system, because this is being driven. It is not being driven by a linear amplifier or a master oscillator. It's with a power amplifier. It's being driven with a power oscillator. So in that respect, the way that it is set up, it is not oscillating at the series resonant mode. It is actually oscillating at the parallel resonant mode. And if we take one coil, so we should take the red coil here for a moment. Let me step on. So if we first of all ignore the green coil, if we were to take away the single wire there and we were to look at the characteristics of what the generator sees. So if we look at what the oscillator sees at its input or its output at the input of the primary coil, effectively it sees one series mode and two parallel modes. It sees a parallel mode, one parallel mode from the primary and one parallel mode from the secondary coil. And of course, you have also the modes coupled through the extra coil. So you have a whole number of modes going on in this system. And where the power oscillator will select stably to oscillate is where that mode has a maximum impedance. So that means it can be made to stably oscillate at the lower parallel mode or at the upper parallel mode. Or if there are additional modes, because with the extra coil there, you also get mode splitting. So there is going to be actually 4 possible parallel modes that it could oscillate at. And the important thing with a power oscillator is to keep it stable. So in other words, I mean, there are interesting effects when the power oscillator starts jumping between the modes, but that's another thing. Ultimately, for the kind of experiments we want to do, you want to keep it stable. And the results that you get are not always the same, depending on which mode you're in. So the lower parallel mode doesn't necessarily display the same kind of results as the upper parallel mode. And when I mean upper and lower, they are either side of the fundamental series mode. That's the low impedance point, input impedance of the coil. So we did experiments both at the lower and the upper, and we were able to adjust that mode of oscillation by making small adjustments to the vacuum variable capacitor. So as we change the vacuum variable capacitor, that basically loads the primary, increases or decreases the loading on the primary, and we emphasize which mode we are actually going to push the power oscillator into oscillating in. And the good thing about it is that it allows the system to resonate very freely. So in other words, it is naturally oscillating where the coil wants to oscillate. And that's quite important for some of the high fidelity and some of the very interesting plasma discharges that you get, particularly things like the swords versus the golden ratio discharge. It does make a difference that the coil is allowed to freely oscillate. The other good thing about the power oscillator is that it can track those modes. So there is a band either side of those modes where the oscillator can actually self-track. So it can self-track the mode. In that way, it actually stays in an optimum position, provided the mode is stable. And it means that you can couple maximum power through that point, either to the upper or to the lower mode. Now, if you get somewhere adjusted, tuned in the center, it's going to flip. So it's going to jump between the lower and the upper, backwards and forwards. And you hear all kinds of cracking and arcing going on. It's a tricky balance, but when you actually get it in the right place, you can get some really remarkable results out of a power oscillator when it's running this kind of way. Of course, you don't have the same control as you do with a master oscillator. With a master oscillator, you can pick any frequency in the range with which the coil will respond or the system will respond, and you can put it, provided you have a reasonable power match at the frequency you select, then you can drive the coil in that way. But of course, you need more infrastructure to do it. So there is a trade-off. There are choices. The component count on a power oscillator is generally much lower than a master oscillator system. You gain some advantages, but you also have some disadvantages. Eric, do you want to say more about the master oscillator versus the power oscillator?
Well, for one thing, a self-oscillating system which is capable of transmitting is against the law. So that's one of the big drawbacks of the oscillator. I want to point out in this case, in order to operate these coils as Tesla had intended them, we would have had to use the so-called series resonant mode, but we could not reach that mode because we didn't have enough buffer capacitors. For the purpose of generating a discharge off of one of the coils, the parallel resonant mode is a little better suited for that because the sending coil is not effectively transmitting to the receiving coil, which would have the power and the potential between the two units and minimize the size of the discharge. So for what we were doing as far as plasma work and that type of stuff goes, the parallel mode would have been more suitable. Now, the way that I've always done this is because I adhere very strictly to FCC regulations because I can't afford to lose my FCC licenses, and it's just kind of a moral issue. So it's supposed to be done with a frequency standard, a stable oscillator that can be varied within the range and then amplified up to the power that's necessary. And that way, like let's say for example, in the situation as shown on the screen here, okay, we drove that with a 100% amplitude modulated rectifier power supply arrangement. And of course, the music sounded good coming out of the flame, but if you tried to listen to it on a radio, it was impossible. The thing was splattering all across the band. The music was just a complete distorted jumble. Now, when you use a master oscillator power amplifier, the music would be perfectly clear because the frequency wouldn't be crawling all over the place, fighting the modulation and the oscillator, you know, all the complications that come out of a self-oscillating system. But it takes 2 racks of equipment to do that, where, you know, with just an experimental setup like this, it's just, you know, a few things on the bench and it's easier, but there's some dangers involved with getting in trouble with the law, and it's just it just causes all kinds of other complications that make it so that you really want to go to the master oscillator power amplifier. Now, the thing is when there's any type of discharge or things are brought near the coil, its frequency changes. So it's advantageous. They're hard to find, but I have one here. I've got a Navy master oscillator that's got a big knob on it. And every turn of the knob is like only a few cycles a second. And you just spin that knob back and forth and you keep on frequency. But what you can do, I do have some RCA units here that are automatic frequency control units, and you have a discriminator, and that provides feedback to the oscillator, and then that way the oscillator is kept on frequency and the signal's absolutely pure. So if you turn on a radio, the music will be in perfect fidelity and it won't be all jumbled up. So that's kind of the pros and cons of the 2 different systems.
Thank you, Eric. Okay, moving on. Okay, so here now we have a clear view of the GU5B in the generator. That's right in front of me. We can see that the tube is powered up. The filament is on. The experimental level shifted supply on its left that I was using, that's a nominally 2 kilowatt level shifted, about 9 kilovolts peak envelope that I was using for the golden ratio discharge in 2023 ESTC. So that formed one part of the hybrid experiment, which we're going to cover. And let me see if I want to come to here. So now we see the RF bay, which Eric is sitting in front, and we see the audio modulator bay that I am just to the left. Eric, would you like to take us through these 2 bays?
So the modulator on the left is a complete unit. That's finished. It's rated for about 1 kilovolt out, and it can modulate to 100% a 2400 volt rectifier power supply. So basically, it's just a big audio amp, and very controllable.
A very big audio amp.
Yeah, well, they get bigger. But at any rate, this is a big one, the 1 kW, and it's actually, both of these bays are basically a kind of modernized and practical version of what was standard equipment on all Navy combat vessels in World War II. I forget what the transmitter was called. I believe a TBK. It's a very impressive looking unit, and actually all the meters that I selected, which are all matched and what have you, are all from the Navy World War II transmitters. They're Westinghouse meters. They're very rugged. They're repairable. They look good. So basically, the modulator is a complete unit. The RF bay, the rectifier power supply, which was literally 10 pounds of shit in a 5-pound bag. I almost gave up trying to get it all in there. There's the network that separates the audio from the DC and then combines them into the modulated DC. So there's a lot of really difficult to find inductance coils and capacitors and what have you to make this band separation filter, so to speak. So the DC doesn't end up backfeeding through the modulation transformer and saturating it. That's on the bottom. And then there's the rectifier power transformers. They're on the back. You can't see that. And then above, there's the item with 3 meters and 1 meter down on the bottom. That is the medium voltage power supply and rectifier control unit. That puts out the bias voltages and screen voltages and what have you. And above that is a Collins Type 32 high-frequency radio transmitter, and that's the master oscillator. So it's got a very stable oscillator in it, and it puts out about 75 to 100 watts to drive the output tubes, which are the panel up on the top end there with the 4 meters. That is designed to basically deliver 2 kilowatts of radio frequency average or 4 kilowatts peak. Underneath it is the grid control unit, which controls the tube bias, selects either continuous wave or audio modulation, because the grids of the power tubes have to operate under different circumstances for different modes of service. And it also has the high-speed mercury-weighted relay cathode switch, so that this thing can operate in a pulse modulated mode to produce the geometric formations in the arc. And also it has the grid tuning unit, which was extracted from a BC-375 World War II aircraft transmitter. And that takes the output, the 50 ohm output of the transmitter, and converts it into about the 5,000 ohm output to feed the grids of the power tubes and the power amplifier up on top, which initially will be 4-250A. I'm at 4-250As. Those can deliver about 2 kilowatts if operated properly. Their publications do not indicate that you can get that much power out of the tubes, but I've learned various techniques from Marsh to get whopping amount of power out of very small tubes. So normally that would be a pair of 4-400s, but they're very expensive, very hard to find, and they require a lot more filament power. But at any rate, the sockets are standard. You could use any tube in this, from a 4-125, 4-250, 4-400, and they will be compatible. So, and then the output of the RF bay goes to the Tesla transformer, which was demonstrated in prior presentations in the conference. So basically, what's going on here is these 2 bays are producing the basically 4,400 volts DC with AM audio modulation superimposed on top of it. And then that's fed to the power oscillator, which Adrian had already pointed out on the bench. So what you're looking at here is about, I don't know, Aaron probably could figure out what the total number of days of effort that went into this thing, but I mean, we're talking about like 3-4 month stretches of me working on this thing every day and 2 other people backing me up. These are incredibly sophisticated pieces of equipment, and they're very good as far as performance and durability and reliability, are very accurate reconstructions of the Navy World War II transmitters, and they're about the same weight and size.
Great, thank you, Eric. And so just to add to that also, if I go on to how we're using these with the experiments, so we're clear on the type of experiments that we're going to be doing. So we are driving the GU5B power oscillator in a number of different ways. So we are driving it through the hybrid level shifted supply that I showed you. That was the white supply to its left on the bench. And that is one set of experimental results that we're going to show you. We also then we take that level shifted power supply away and we connect it to the DC high voltage RF rectified bay, which is the one that Eric is sitting in front of here in the picture. That provides a straight DC. So at nominally 4400 volts, when we have the 2 in series, we can see the 2 are in series because we have these adjustable jumpers at the bottom here, which allow us to put the 2 nominally 2400 volts, Eric?
2200.
2200, yes. So 2200, we can put them in parallel or we can put them in series. And here we have them connected in series with these jumpers. So that gives us a 4400 DC. That provides the anode supply for the GU5B power oscillator. So in effect, it becomes then a powerful flame. It's just a DC.
Let me add one thing. So let's say we have the 2200 volts DC. So the modulation transformer is the AC out is such a voltage that the peak to peak voltage is also 2200 to 2400 in that range. So basically at an audio rate, the power supply voltage is going from 0 to twice the DC voltage. So when we have this thing on the 4400 volt tap and we force the modulator into its full power output capability, then basically it's double the voltage to the tube. It's 8,800 volts to the tube.
Yeah, we're hitting at 8,800, which is why, if you remember at the beginning, I said that this tube is very robust. It is very robust for very high anode voltages and way beyond its nominally rated. It's a 5 kilovolt peak anode voltage is in its ratings, but we have discovered empirically that it is actually robust to much higher voltages than that. And the tube had no difficulty in doing the experiments that we actually did here. So as Eric says, then we finally combine the audio modulator, and that forms the last part of the experiment. So we're going to go through what the different kind of discharges and the different kind of characteristics that you get from those various experimental setups.
Adrian, when do you want to open up for questions? Do you want to do it before we get too far, or hold them all for the end, or how do you?
I think we need to hold them for the end. I think, Aaron.
Just all the way at the end. Okay.
I think so. Yeah, because there's otherwise it somewhat breaks the flow. There's quite a lot to get through.
Okay.
Okay, so this is the result of running the GU5B generator in the hybrid setup. So it's now using the level shifted supply. That's nominally four microwave oven transformers level shifted. So nominally that will give you about 9 kilovolts peak AC at the line cycle, which is 60 cycles. And as I described I went into a lot of detail about how this oscillator works in the golden ratio discharge presentation that I did in 2023, and what happens when you are below a certain frequency threshold in the lower or upper mode, and what happens when you are above that threshold in the lower and upper mode. So if you are interested in understanding how all that works with this kind of Armstrong oscillator, then I recommend going and looking at that presentation on eMedia Press. You can download that, buy that, download it from eMedia Press, and it goes into a lot of detail about this type and form of discharge based upon this type of apparatus before we get to the other types of apparatus. And this is typically what's called a sword discharge. So they are long, thin, straight, well-defined. And typically these are more characteristic in the lower parallel mode. They can also appear in both parallel modes, but they're much more stable and easier to generate with the lower parallel mode, which is what we're using here. Eric, do you want to add anything about this kind of discharge?
Well, there's two things. As you had pointed out, and this kind of verified that, is you don't really get the detail in the discharges when you get down into the medium frequency range, like here, which is about 900 kilocycles.
Yeah.
So it's a different type of discharge, completely different type of discharge when you get down in the medium and long wave range than it is when you operate in the high frequency range, which is most likely due to the fact that as you go up in frequency, the displacement current goes up proportionately, and there's more ether, you might say, for the discharge to dance in. The other thing is the series resonant mode will produce discharges just as effectively as long as you're not transmitting into another coil and robbing half your power. I've always used the series resonant mode myself because that was the one that Tesla was using. And my main interest is radio transmission, and you have to use the series mode for that.
Indeed. Yeah. Okay, moving to the next. Another example of the same. Very straight, quite long. They are in the region of about 15 to 20 centimeters in length.
So one thing I'll point out is the discharge is, there's the part you see, and then there's the part that you can't see.
Mm-hmm.
The part you can't see is this current is flowing into, this is a conduction current you're looking at, and it's flowing into displacement current, which exists in the so-called ether that you cannot see. And this is the thing that makes it frequency dependent. So that's why someone may think it's a stupid question to ask that didn't know, well, what positive and negative, there's got to be two terminals. Why is a discharge jumping away from ground and out into space? Why isn't it trying to jump to another terminal? And that's because it's kind of like a crack in the ether going into the displacement current. So actually, under certain circumstances, with proper backlighting and what have you that I did in the days when I was doing all this out at RCA, there's actually a complementary set of discharges that doesn't emit light, it absorbs light. So there's a lot more going on here than is
meets the eye.
Visible.
Absolutely.
And that's why it does what it does.
I agree fully. This is it would only be seeing it at face value to essentially just take this as just a discharge. It is a very fascinating and interesting, almost experimental laboratory, just working with, really working. I mean, the real underlying purpose for some of these experiments for me is really starting to get down to answer some of those underlying questions about how the nature of electricity really works. And these kinds,
also how the nature of nature works.
Exactly. Which those are one and the two the same thing. Yeah. So it is one of these types of discharges, as I also covered in the presentation at ESTC last year, is they give you an opportunity to see how electricity manifests that natural order. And it's something that people don't really necessarily at first realize. I mean, you see fractals and the golden ratio in many places in the natural order. Why not also in the electrical world? And it's these kinds of experiments and these kinds of discharges that show that all of those natural order principles and processes are going on inside electricity as well. And there's as much that you can't see, as Eric says, that you can see. And formulating those experiments, looking at how the vibrations work. I mean, this is the most simple discharge in a way. I mean, when you start adding harmonics, looking at how it changes over the different modes, looking how it changes according to geometry, to aspect ratio, to the way in which the coil is loaded, the way in which it is arranged with a counterpoise or not a counterpoise. Does it have a resonant cavity? Is it allowed to freely oscillate, or is it driven? All of these are factors in exploring within this experimental laboratory. So this is really why we pursue this as interesting. It's not just about making sparks. I mean, that of course is interesting. It's entertainment. People like to see sparks. But there is a much deeper aspect to the reason for doing this. And exploring electricity, Eric and I we are amazed and with awe when we actually looked at this experiment and looked at the range of possible things that we were coming out of it. And we will add along the way some of the unusual stuff that happened. There were certain kind of discharges coming off of strange places in the coil, which we had no idea what was going on there. But we'll get to that. There were some, so it is really, I suppose what I want to underline here is doing these kinds of experiments is an opportunity to open up a window into the natural order that you wouldn't necessarily otherwise be able to do. And that's what makes this so fascinating. And also, it also really takes those first steps in trying to understand that there is another way to look at all of this. Science electromagnetism doesn't have anywhere near all of the answers in terms of what is going on with electricity, how it works, and how it reflects the natural order. And that is the purpose for some of this work. Okay, moving on. Okay, here's Eric. Do you want to say what you're doing here and why?
Well, this is what I think we were tuning it up.
Indeed. And
so the fluorescent lamp is the universal field strength indicator.
Indeed. I suspect here it looks like we're considering what to do next. But it also it also gives you an insight here to there is a certain amount of power transfer. This is what Eric was saying earlier about we are not doing power transmission experiments here like was done in 2019. That would require the series mode. It requires a matching between and it requires the cavity to be balanced. We're using it here as a counterpoise. But we can see that there is some power transfer nonetheless. Always there will be some because we have the longitudinal mode bouncing backwards and forwards across this cavity, irrespective of whether we're using it as a counterpoise or not. But we do have it tuned. So we can see at the far end, if we look at the top here, there is a small discharge at what we might say is the receiver end of the cavity. But we're not using it as a receiver here. We're using it as a reciprocal part of the cavity so that energy can bounce backwards and forwards and is contained in the cavity rather than dissipated or transmitting out into places it shouldn't be transmitted. And of course, then we have that. That is the same discharge we were looking at in the previous slide.
One thing I'll point out, you look at that discharge, bring it back up a little bit again. We can see make it a little bigger. If those of you that live outdoors in the northern latitudes, you will notice that as the very top form on the top of a fir tree. It's the same three legs at the same three angle. The part of the tree that's going from counter space into space makes that exact same proportion, except it's green rather than purple.
Indeed. This is what we mean by exploring the principles of the natural order. They're everywhere if you look. So this is a close-up of the discharge that was on the counterpoise coil. So when I showed here that little tiny discharge up the top on the green coil, this is, so you see it is an accurate replica of exactly what was going on the red coil at the generator end. It is the same in form and nature. Is obviously that the maximum potential developed across the green coil is considerably less because we are not transferring power. The point of this is not to transfer power from one to the other and back. That is about perspective. That is about 5 centimeters long. Whereas at the generator end, it was about 15 to 20 centimeters long. Again, this is not also about the length of the discharge, which has to do with the amount of stored energy and also the potential magnified across the coil. The magnification here is not enormous. So these discharges are not several foot long, like you might get in some presentation Tesla coils that you see online. But that's not the purpose. The purpose is the structure of the form reflected in the natural order. Eric looking intently at the bay, making sure that all the needles are where they should be. That looks like it's prior to a turn on. And here now, we've done the experiments. We're now setting up to use the 4400 volt. In actual fact, we're just moving it from the parallel to series configuration, I think, here. The RF unit. So we're going to be using this lower section, the DC rectifier. The rest of it here, some of this is functional, but we're not using it in the experiment. Okay, so this is the discharge. This is what Eric actually calls the burning bush, which is quite appropriate. It looks like a burning bush. That is about, to give you perspective, that's at I believe 4400 volts, and that is about 10 centimeters high. There is no modulation at this stage. So this is the product of the power oscillator being driven from 4400 volts DC and it's oscillating at the lower parallel mode. And this is typically what you get out from it. So it's stable. Eric, do you want to add some more about the burning bush?
No, other than that's about 4,000 watts of power being dissipated. The thing's quite hot.
Yes, it is quite hot. It's nice because you have that very white intensity in the center. So it's very current rich. And as a result, being very current rich, it gives a lot of opportunity to it to morph into other things. And particularly as you add the modulation, it starts to morph into other types of shapes. Eric, do you want to say a little bit about the branches and the roots?
Yeah, that's a frequency dependent thing. So when you go on one side, when the frequency's high, it leans towards the capacitive side, if I remember right.
Yep.
That would be the one, I believe, where you get if I remember right, when you go higher in frequency,
the branches.
You get the branch formation.
Yes.
Organic formation. In other words, you get the part of the tree that's out of the ground. Mm-hmm. And then when you go to the other side of the resonant frequency, you get the tap root, which is somewhat like the sword type of formation. And that is what's underground. So it's interesting how this is what you have to have a variable oscillator, master oscillator for, is so that you can accurately go back and forth and home in on the optimal branch or root, even though you can do that to a certain extent with a self-oscillator, but it's trying to fight you ultimately. So, but it will do it. And then when you're in the middle, you get a balanced pattern, which is kind of bold. And when there's no pulse modulation or audio modulation, then you get this flame, which is very dynamic. I mean, it's frozen in time here, but the thing tends to fill out on the average. And it makes a nice quiet plasma medium in which to add the audio modulation or the music. And but it's not suited. It will not produce the branches or the roots because that requires pulses less than 1/10 of a second in length. So if this was pulsed with pulses 1/10 second of a length pulse duration or shorter, then this discharge tends to reach out many times beyond the normal arc discharge distance.
Indeed.
Many times beyond.
And Eric, what is important about the 1/10 of a second? Why is it 1/10 of a second?
Well, I don't really know. It's just if you hold the power on longer than that, it collapses into this flame. So basically these extensions of the discharge leaping outward in kind of a spiral fashion back inward on themselves, they can't hold steady in space. They have to be there for a short interval. They will not hold steady. It sounds to me like it's some kind of displacement current situation. So if the power is continuous wave, then there's no transient for the displacement current effect to present itself, because displacement current cannot exist in a steady state.
Mm-hmm. Another version of the burning bush. You see, it has this core in the center. This is like it's a formless state. In other words, it's a steady formless state.
It's a plasma kind of.
Yeah, it's like
in the organic sense. It's a medium waiting to be worked.
Yes, exactly. That's a good way to express it. It is a medium waiting for something to be impressed upon it. Okay, this is the product of how it changes when you have 10 pulses per second modulation. So now much of the organic plasma at the middle is now starting to take a form. So in other words, it's now starting to form tendrils, and those tendrils tend to reach out but they tend to reach upwards. Like this. This is similar. This is actually similar to a root configuration, Eric, because it's actually at the lower. It's actually at the lower parallel mode we were doing this.
Yeah, I'm not certain.
It's a frequency which is lower than the central series mode. Also still at 10 pulses per second modulation. Now, this is an interesting scenario when you tune it between this is actually the transition between the lower and the upper parallel mode. So we're actually in the process of jumping it from the lower parallel mode to the upper parallel mode. And right in the middle, it collapses, the discharge collapses into the electrode, and it comes off the electrode rather than emanating off the tip. Eric, do you want to speak to this a little bit?
Yeah, I don't recall exactly how we had arrived at this, so I can't comment. But it is interesting that the extensions now are completely horizontal.
Yes.
The pulse duration looks a lot shorter now.
It's still the same.
Is it?
It's still 10 pulses per second, but what we did here is we actually adjusted the vacuum variable capacitor to get it to move from the lower parallel mode to the upper. And this is the transition. It's not in the upper mode yet. It's in the transition.
Okay.
Because we were taking video, because I took these pictures from the video, I was able to get the frame. I was able to get the frame where it actually moved from one to the other.
Yeah, my mind, I think at this point was mostly concentrated on not an erupting fireball or a massive cloud of smoke.
Indeed. Well, that was a slide of you looking carefully at the instruments.
Very carefully. Yeah.
You know, what comes to mind to me when I saw that, and I did see it on the video when I first watched it, it only existed for a second or two, but it seems to me that the difference between the lower discharge and the upper discharge represents the change in frequency. So the wavelength is actually shifting it up the mast, possibly. Tesla talked about that, and that's why he put a little electrode a little longer on his hemisphere to control the breakout point. And I'm just curious. I'm just wondering if that might be what we're seeing here.
It sounds reasonable,
In this case, I don't think that there's going to be any change in potential along the length of the mast, because this is being driven with sine waves, and Tesla was using more of a rectangular wave. But I'm not quick to jump to any conclusions here on this.
We'll call it work in progress. This gives a good example of the range of types of effects, and even trying to understand how such a simple effect should arise is actually quite challenging in these systems. But if you video them and you capture them, you can see these kinds of effects going on. And that is really the fascination of exploring the space, if you like, the space in which you can move this system into, and the different effects that it has with electricity.
That's one thing that's going on here, because as this thing moves around in frequency, the shape of the entire field gets older, because there's different potentials in different spots along the coil and what have you. So again, I think it's important to realize here that the discharge is only a very small part of the invisible structure which surrounds the entire apparatus.
Indeed.
And because of the multiple coils, that could be very complex.
Most likely.
Yeah. And that's why we ended up with that really bizarre discharge that there was absolutely no explanation for, because there wasn't enough potential from point A to point B to substantiate a discharge like that. And it was as straight as being drawn by a ruler. Yep. And it was red, and there was no reason for it to be red. It's not a spectral component to anything that was involved.
Explain more, Eric, where it came from, where it came from in the system.
It was a result of the violent transient that the power supply, self-modulated power supply thing with the microwave oven transformers and all that, that thing produces hideous transients when you turn it on.
Well, especially because when you run it with an SCR. So because its power is being controlled by an SCR, it creates enormously nonlinear transients.
Yeah, all over the place. The saturation of the cores and the transformers, and I mean, that's why stuff was burning up all the time. This is just really, it's not a good circuit design. It's very popular. Everyone uses it because it's cheap and fast, but it's very dangerous and it tends to destroy stuff. So you had switched the thing on that particular power supply, and that onset transient, it leapt out of the side of the extra coil towards the secondary coil, which is kind of odd because they're connected to each other.
Yep.
And it looked like a crack in the ether.
Yes. And it was bright red. I agree. It was bright red. We both saw it in that moment.
Yeah. And then when the transient passed, then that was the end of it.
Yep.
But those are the things that end up disintegrating your equipment. That's why these transients are, they're not desirable.
They are nonetheless fascinating.
Yeah, until that costly piece of equipment gets turned into a fusillade of spark, smoke, and fire.
Indeed. That unfortunately is part of the risk. Okay, moving on. Okay, so this is now closer to the upper parallel mode. So let's just skip back. That was the lower parallel mode. This was the transition between the two. That is now into the upper parallel, just into the upper parallel mode. And you see it's now starting there. It's contained in the breakout. There it's leaping off the breakout. There it's contained in the breakout. There it's started. Now it's a combination. It's not fully in the parallel mode at this stage. That's why I selected this one from the video. Now it's almost completely in the upper parallel mode. Right, let's go. So this now is in the upper parallel mode. That's just emerging into the upper parallel mode. That's the transition. It's actually in both. It's flipping backwards and forwards very quickly between the lower and the upper. That's just in the lower. These are much well-defined swords. These are what you would call classical swords. Very, very current rich. There's a lot of power in there. It's about 10 centimeters long. So this primary streamer, the larger one, is about 10 centimeters in length. Eric, did you want to add anything on this transition and the lower and the upper and what changes with the discharge?
No, I'm not familiar with that because I wasn't paying attention to what you were doing at that point. I was just trying to keep everything operating.
Yeah, you were watching the making sure nothing blew up.
I got to make sure, to slam that abort switch as fast as I can.
Yeah.
That's what I got to concentrate on.
That's why it's good to have the two of us doing it.
Yeah.
That's just at a distance. Here's very nice because here you start to see the extinguishing. So you start to see these streamers extinguishing. It's what Eric was saying about the conduction current moving to the displacement current. So it's actually heading outwards, and what you got left with at the bottom here where I'm moving the mouse is just the gaseous oxidized composites in the air. They disappear very, very quickly, but there is still a certain amount of current in the end of the streamer, but it's exhausting from the source. And this big one coming out is just starting to do the same. It's just starting to exhaust at the source point.
It's interesting how precisely straight that is.
Yes.
You can see now that, go back to that one. Go back to the one you had before. No, the one before. The one you just flipped through. No? What was the one? Yeah, so you can see right where your arrow is. See how one of them is? Yeah, that's a valuable photograph there.
Yeah, that's just a little bit left. So the little bit of the conduction current just still moving out in the displacement.
So that's basically, that's a breakdown within the displacement current.
Uh-huh.
Another name for a displacement current is capacitor current. So the current that flows through a capacitor has nothing to do with electrons whatsoever.
Indeed.
So, which is, of course, what everybody's taught. It's the current that flows through the dielectric. It's not a conduction current, it's a displacement current, and it cannot exist in a steady state.
Mm-hmm. Yeah, that is a nice picture, that one. It's just the last. So that's the beginning. So that's the beginning of the extinction. And then that's where it's essentially just about to go out of manifestation. Let's say it that way. Okay, this is a shot of the ballast lamps in the audio modulator bay. Eric, do you want to speak a little bit about what these are for?
Yeah, these are to make sure that if anything goes, like there's an oscillation or a transient, it doesn't damage the modulation transformer. So it's like a self-adjusting resistance across the transformer. So if a sudden surge comes through, because the resistance of the lamps depends on their temperature, if the lights are out or dim and a quick transient comes through, which could damage the modulation transformer, the lamps will act like a short circuit. So it's kind of like a shunt safety valve, so to speak. And it also gives you a good indication of how much power the thing's putting out. So this is a 2,400 volt light bank. So there's 20 120 volt lamps hooked in series. And so this is kind of like your output voltmeter. It robs power. So basically, once everything's all tuned up and you're comfortable with what's happening, then you take it out of the circuit.
And how high did we get the modulation, Eric, in this experiment? Did we get to 100% modulation? I seem to remember we couldn't get that high.
Well, there were some problems that one of the transformers in the assembly was something was wrong with it, some kind of weird design or something. So the core in it started to saturate as you reached 100% modulation, but the saturation curve was such as it acted kind of like a amplitude limiter, so that you wouldn't have to worry about something coming through and just knocking the modulator silly, or burning up the RF tube or what have you. But we were operating at 100% modulation. I did get it to that point.
We did. Okay, good.
Yeah.
I think that's the two of us looking at everything, very happy that nothing blew up whilst we were doing the experiment.
Well, it was designed not to blow up.
Exactly, and it didn't.
It didn't.
It didn't. Well, I mean, on both sides.
Yeah, but, that's been my ongoing reputation as an electrical engineer is everything I build, when you close the main breaker, it works.
Indeed.
And sometimes even when you open the main breaker, the light still stays.
Still works.
That really puzzles me.
Yeah.
That's why I was known as the wizard after that episode. So a lot of care went into designing those things.
Oh, yes.
Building them. But I still never trust turning the switch on at first. I'm always scared.
I'm the same. I'm the same. When you turn on the system for the first time and throw the switch, you just have to stand back.
Yeah. I think
Here,
now
I think this is
put the music in.
yes. Actually, I have a little note at the top here. This is the flame speaker turn on. So this slide is the flame speaker turn on. So now we have, so just so to be clear what this is, so obviously using the same GU5B generator, we're using the 4400 volts. In actual fact, we haven't got 4400 volts. It's set here for 20.
Yeah.
It's on the, yes, because combined to the two of them, will produce a peak, of about, it will produce a peak of 4,400. So
yeah, and the bypass on the modulation choke has been removed. So now we're getting ready to go to the AM transmitter mode.
Yeah. Okay, so this is the flame speaker with a single tone. So now imagine that before there was the burning bush. So without the single tone, you've got the burning bush there. But now when you put the single tone, I believe it was about 1 kilocycle.
Yeah, somewhere around, I think 800.
Something.
Yeah.
So this is what it comes now. You take out that plasma. That plasma goes in the center, and you just get the very fine filaments and tendrils. And those tendrils change as the tone changes. As the frequency of the tone changes. Eric, do you want to add more on that?
No, I'm not. You got the notes of what we were doing. I'm just kind of going along. Now, do we have it so you can actually hear the music and the birds and all that kind of stuff, or is this all stills?
No, these are stills because I can't play it through the screen share. I don't know. Maybe Aaron may be able to play something, but we can't do it. We can't play the video through this method of streaming.
No, that's very unfortunate.
So this is now what these were doing with a single tone. You see they're a little bit brighter than they were before.
Yeah, now we're up to 2,400 volts AC out of the modulator.
Yeah. So these are basically fully illuminated.
Yeah.
And they are fully illuminated here because they're stopping the modulation transformer from becoming saturated any further. Huh?
No, it's not a saturation. It's basically to make sure that because the modulation transformer has so much inductance, if you break the current in it immediately, it'll produce a violent transient and punch holes in the winding. Indeed,
yep. And this is basically soaking that transient up.
Yeah, it's in case that transient was ever to happen, these are, they're basically a shunt, and also they're a power indicator. So I know, how from these I can get an idea of how much power the modulator is putting out.
Mm-hmm. Okay, this is a bird call background. So this is the bird call. There was a bird piece of music with bird sounds. And this is the background. So the background discharge in the bird call.
Boy, it's tragic we can't play the audio.
Yeah. That's the actual. Let me just check with Aaron. Aaron, is there any way to play that in the current setup?
I can try to just screen share the YouTube video and see if the audio works. I know we've always had these audio glitches that didn't make sense before, but I can try it.
I've just got a few more slides, and then maybe we just tried to see whether we could do that.
Sure. Yeah.
So this is the bird call. This is bark. Somehow the discharge likes bark. Tell us why the discharge likes bark, Eric.
Because bark's music is the very epitome of the natural order.
Indeed. They go together. This is bark again. That's when the intensity of the background, the bark, was very low. So that was what it was like with the high intensity, and this was like with the low intensity. So in a quiet part of the bark music. This is with, we did try running with the series high voltage. So this is with the high voltage rectifier in series rather than parallel. It got quite large. Basically, I mean, what we're up to with full modulation, we're be up to 8,800 volts on this.
Yeah, at 100% modulation.
Yeah. That was an experiment well done. You just shake hands on an experiment well done, and nothing burnt out, and we lived to tell the tale. Aaron, if you are able to play a few minutes of that sound, it will be great. I don't know if it will work across the Zoom, but we can try. Hakasis, do you know whether that will work across Zoom?
He would have to play it directly through his video, I think. I'm not sure if we're set for it.
Okay. All right.
But it is on YouTube. We got that on YouTube.
Yeah, this whole experiment is on YouTube.
So like all the bird chirps and all that kind of stuff.
Yeah, it's all on the YouTube.
So at least it's accessible. That's good.
Yes. These stills, I took these directly because we didn't have any still photos in the experiment. All of these photos that we show here actually came out of the video. So I went through the video and took out stills of things as we went along, which was good because that was how we got the discharge in the different stages.
Yeah, you got to freeze it in time, otherwise you can't really see what's going on.
Yeah. Well, Aaron, are you there?
Yeah. Do you want me to try to play a YouTube video and see if
see if we could get the bark or the bird calls or something.
Okay, let me do it. Okay, so this is going to end your screen sharing.
But that's fine. That's fine. I've finished the presentation now.
Okay. Can you see that screenshot of the video?
Yes.
Okay, let me see. Now, could you hear that at all?
No.
Really?
Yeah.
No.
Now it's going to do like still frames, and then you might get some of the audio, but no.
It doesn't. I mean, my experience streaming video through Zoom or this kind of thing doesn't work.
Can you put the video, or you can put the YouTube address up so people can switch to that?
Yeah, hold on a second. If I can, okay, so in the group chat for everybody here, let me stop the share real quick. So hold on a second. Okay, in the group chat at the bottom of your screen, there's an icon that says chat, and if you click on that, it's basically the page where the Colorado Springs presentation is, because if you just scroll down on there, it's below the preview videos, and that'll have all the different audio demonstrations.
Right. And Aaron, we can open up to questions now if you would like.
Okay. So now for questions, before you, please don't unmute yourself. I'll unmute you. Just at the bottom of the screen, there's a little smiley face with a plus sign next to his head that says reactions. If you click that, just click the button that says raise hand, and I'll know to unmute you and that you have a question. And when you're unmuted, please introduce yourself, your name, where you're from, who you're asking the question to, and then just be real laser beam focused on what the question is instead of continuing to just go on, going on and on. We're at hour and a half right now, and hopefully we can kind of get wrapped up right in about a half an hour or so. Okay, so Don, I know that you've been wanting to ask a question for a bit. You should be able to.
Can you hear me?
Yeah, go for it.
Hi, my name's Donald Best. I live in the Amazon currently. And the first question I have is, are you working primarily with transverse? Is the goal to work with transverse waves or longitudinal waves? And whoever knows the answer can answer that for me.
Yeah, that doesn't really apply at this point. We're working with plasmas.
Okay. And then I noticed that because I do see the similarities in the coil configuration to the Colorado Springs, and I was just wondering, what is your understanding of what Colorado Springs was? How did it put the energy into the Earth?
It acts like a monopolar transmitter. So
Yeah,
it doesn't need, there's no way that you can transmit into the ground if you're going to use the ground as ground. So the question is what are you going to ground to? So the Tesla transformer provides a ground in another dimension in the vernacular. That's not really the best way to put it, but it doesn't need to be grounded to anything because the connection to the Earth is it's not a ground terminal, it's the hot terminal. It's designed to transmit into the Earth. Now for the plasma generation stuff, we turn the whole thing around. So then the other end is connected to ground if you're in the series mode, or a counterpoise if you're in the parallel mode. Then you're transmitting not into space, but you're transmitting into the plasma. Now, Tesla had done a lot of experiments and details and what have you to somehow get a current to flow in the ground at such a frequency, such a wavelength that it started to compound on itself in the Earth.
Right. Did he call that a damped wave?
Yeah. So no one knows how he accomplished that, because if you told anybody, that at his frequency of 45 kilocycles, you're going to get that kind of effect inside the Earth, they go, oh, well, that's impossible. The frequency's way too high and what have you. But there's no way that he could have got the fire and the brimstone and everything that was going on when he got that thing fully operational just on the power he was receiving from the public utility system. The power flow had gone way beyond any of that. And it was backfeeding down the power line and putting standing waves in the generator and the generating station, and burned out all the generators, and horses were jumping up off the ground with sparks following their feet, like, something out of 20,000 Leagues Under the Sea, when the natives raid the boat, and Captain Nemo charges the hull.
So
I will also just add,
if somebody could have recorded that, okay, and we were able to see today what actually happened there, it'd be beyond anything that Steven Spielberg could cook up.
Yeah, indeed. I will just add, if I could just add on to what Eric is saying. Also, the whole Colorado Spring experiment, I feel, from the experiments that we've done and investigations over a long period of time, it is not what it appears to be at face value. So it is not a transmit station and a receive station and a conductor in between the transmit and the receive station. Is not. We've done enough what might be called telluric experiments, if you can call them that, to understand that you are not transmitting energy through the ground from a transmitter to a receiver. It has much more to do with, or what we've discovered so far, it has much more to do with stimulating the Earth. So there is a stimulation going on here. And when you put that signature in, when you stimulate the Earth into active synchronicity with whatever it is that you're vibrating at, then you create a completely different effect. Then things start to come into synchronicity. So wherever you put a so-called receiver in the ground, they also get stimulated. So it is a coherent phenomena, or at least the best we understand it, it is a coherent phenomena. Whether that makes it longitudinal or not remains to be seen. I mean, there is a lot of talk of longitudinal modes and all those kinds of things, but it is a stimulated, coherent experiment and apparatus. Let me just leave it like that.
Just to segue on, because I do remember reading that Tesla said that the most expensive part of Wardenclyffe was the pylons that he had to pound into the earth so that he could find a secure footing from which to push the current that washes over the earth. And if you think of a water in a wave, it has two expressions. It has a longitudinal expression that's going up and down, and it has a transverse expression that is going crossways, the one that we see. And I would say that at the point at which you get a standing wave put on the earth, that all the bottom points of that wave will have a longitudinal compressional force to the center of the earth, and those will all meet each other and they will form a damped wave. And I believe that is the crux of the system that Tesla was putting together. Beyond that, I just have one other question. How do you define, or how do you, because we use longitudinal and transverse waves, and I'm just curious what you guys are thinking of how a longitudinal wave is created. What is a longitudinal wave and how is it created in your thinking?
A longitudinal wave is what flows into displacement current. That's not a transverse wave. That's a longitudinal wave. Everything's in series. It's like a sound wave in the ether. A transverse wave only can happen at a boundary. It can't happen by itself in free space. That's why the whole Einsteinian Maxwell concept of light waves being transverse electromagnetic waves, that's not really possible. But it's become ordained.
If I could put it a different way, a transverse wave is what happens within the wire, and the longitudinal wave is what happens in the capacitor.
So
I would just also add on. I would just also add that I just want to also add something to what Eric also shared there. Is when we consider longitudinal or transverse modes, then we are talking about transference. So we are talking about a mechanism of transferring power. But the mode is different. So for example, if we go back to the basis of Eric Dollard's work, where he talks about the magnetic induction field and the dielectric induction field, and the combination of the relationship of those between those, it actually defines everything outwards in terms of how electricity responds in a moment. So the relationship between those two induction fields is critical. And if you look at the relationship between them in the longitudinal mode and the relationship between those two induction fields in the transverse mode, they are interacting with each other differently, but they are nonetheless, it is a linear interaction, and it leads to transference between one point to another. It is not a displacement phenomena. And I'm not talking about the displacement current. I mean, Eric's talking about the displacement current. He's just going a little bit more detail. So ultimately, what you find is that the transverse mode is coherent in time, but not in space. But the longitudinal mode is the other way around. So it is coherent in space, but not in time. And you can measure that across the cavity of a long. There's one of the nice, interesting things about a TMT system is you can measure that across that longitudinal mode across the cavity, because when you look at the voltage and current along the single wire, you will find that there is a changing phase relationship. They meet a node. At the lowest mode, they meet a node, a null in the center, and then their phase relationship changes across the transformer as you go outwards from that node, which is characteristic of the longitudinal mode. That's what I would add to what Eric is sharing.
Just a segue, because when I try to teach very young children on the difference between transverse and longitudinal waves, and tell me if my perception is correct, because I think of ether as having no surface tension. And so I think of ether as impossible to stir. And to me, stirring is equivalent to a transverse wave. It's like if you take a string and it's loose and you turn it in circles. As it goes across, there's a time component and there's an energy component that is lost as it moves, right? But you can't get that motion out of, let's say, liquid helium, because the stick doesn't have any, it cannot push anything because there's no surface tension in the liquid helium. So if you use a compressional force in liquid helium, or something that doesn't have any surface tension, then, and it's all, and it has no compression possible, you can actually create a force at this point, and it can be felt somewhere else at that exact same time. And to me, that is more akin to a longitudinal wave. Would that be correct?
That's a pretty good way of looking at it. But what I typically use is the ocean. So the waves on the surface of the ocean are transverse. So you throw a float in there. The float doesn't really want to go anywhere. It just wants to go up and down.
Correct.
So basically the waves move, but the water is not moving, so to speak. It's not moving in the direction to travel. But let's say that you have a tidal wave, or a depth charge is set off. Then there's no wave appears on the surface to speak of. It and where the transverse waves, the waves on the surface might only move so many miles per hour, which is not faster than you normally experience in day-to-day life activities. The longitudinal wave moves at incredible speeds. It moves at 700 miles per hour. There's no evidence of it from the surface at all until you start to get to a situation where the water's not deep enough to support it anymore, and then it turns into a transverse wave, and that's when it's deadly. But out in the middle of the ocean, because the velocity is so high, the wavelength is so long, is a massive tsunami can pass underneath your ship, and you're not really going to notice much of anything. Yet a wave of that intensity as a transverse wave will end up destroying the ship.
Thank you very much for your time.
Yeah,
and I would also add, it's often mistaken that the longitudinal mode basically is a standing wave, like a sound wave, but that's actually not true. With the dielectric induction field and the magnetic induction field, you are talking about a dynamic relationship in the moment. So they are longitudinal with each other in the moment. They haven't got to go to the end of the cavity, bounce back in order to form a standing wave, in order to form the longitudinal mode. That's often misunderstood with the longitudinal mode.
I do get that. Yeah.
Okay.
Thank you very much for your time. I appreciate very much the deep thought that you guys are sharing with me here.
Well, thank you for your questions. Those are good questions.
And if you go to ericpdollar.com, there's it's a free link, or in the main menu, there's a free menu option and a little pop-up for videos and papers. And if you scroll down to videos, there's about 7 or 8 videos or so, and there's one on the transverse and longitudinal electric waves and Tesla's longitudinal electricity. And these are old videos, I think, from the 80s from Borderlands, and you can watch these for free on YouTube. And these are some of Eric's older videos where he kind of goes into the distinction between them. And
are those with Peter Lindemann?
No.
Yeah.
Oh, yeah, they are. Here, I'll just show it real quick, and then maybe we can take a question from somebody else. I just showed this a second ago. So basically, if you come here to Eric's page, there's this free menu option right here. Mouse over it, mouse over videos, and then go to the very bottom one that says transverse and longitudinal electric waves, and you click that. It'll bring you to this page, and there's these 2 Borderland videos where Eric kind of goes into the distinctions, and he describes the difference between them, and then he does some experiments. And there's 2 videos on that page. So these are some old classics that, if you haven't seen those and you're interested in this, it's recommended to at least look at those.
Eric, was that you in the video there?
Yeah.
You haven't aged a day, huh?
Yeah. That's back when I was known as the wild man of Bolinas.
you haven't aged a day.
Okay, let's see in the chat. I see Reginald was raising his hand. Let's see if you have a question. Reginald, if you want to go ahead and unmute yourself and ask your question. If you're still there.
Pronounced just like it's spelled. It's Juzang.
Okay, yeah, go ahead.
Okay, I'm new to all of this, and I find it to be quite interesting. So am I to interpret this as this is an alternative way to be able to access or gain power from within the planet as opposed to using your local service provider?
Not really. It depends how far you want to go. I mean, what we are demonstrating here, or what we have been talking about, is some of the electrical properties that you can, or fundamentals or underlying principles and processes that define electricity in these kinds of Tesla systems. So that's what we were really showing. I mean, in terms of generating electricity or energy from the earth and those kinds of things, these are very popularized and things that are often talked about, and have really yet to be demonstrated by anyone to any degree in success. So maybe there is something there with that, but it's certainly not easy to get to. Eric, what would you say?
Yeah, pretty much it's the same. Whatever you said, is kind of where it's at. Yeah. In my mind also is it's not really, something you can tap into and start sucking massive quantities of power. It probably would result in a complete electromagnetic catastrophe if somehow you opened that portal up. And because when these things are just operating, with the energy that they put into the system, as Colorado Springs demonstrated in Tesla's work, the effects become surreal, to say the least. If you kept going with that, I don't think it would turn out too well. So I don't see it as a device for tapping energy from the other side, so to speak. But I won't say that it's impossible. But I'd say that it's so difficult that I couldn't even conceive of beginning a project like that without at least $15 to $30 million on hand and a fence around it with two Marines with M16s at the gate.
There is just something, Reginald, just something to consider. There was a very famous expression from Tesla himself, which was basically, there will come a time where man will learn to hook their experiments and their machines and apparatus to the very will work of nature. And in there, I believe that there is a truth. There's an underlying hidden truth there. But it's not, as Eric said, it's not about sucking power out. It's about coming a part of a synchronous regenerative cycle. So you are coming a part of the cycle of the natural order. And that means that power in the natural order will automatically flow through whatever it is that you have actually attached to that cycle. It needs to go in and it needs to go out. So you can't just take something. It has to be a reciprocal process of give and take. And the same is true of electricity.
I've got an analogy that I often use. Okay, right now where we're seated appears to be stationary, but it's not. Okay, at the equator, the Earth is rotating at 1,000 miles an hour. The solar system, the sun, everything is flying through space. So we're talking about orders of magnitude of hundreds of thousands of miles per hour to millions of miles per hour. We're all flying through space. Now, if I take a quarter and hold it up in my hand, that quarter is moving, let's say, at 250,000 miles an hour. Therefore, that quantity of stored energy exists in the mass of that quarter. Now, let's say that I hold up a metal plate and stop it. What kind of explosion do you think that would make? That's how much energy exists in a potential form. But let's say now that we figure out a way to tap into that. Let's say we figured out a way to tap into the 1,000 miles per hour and we start sucking all this power out of it. Oh, now we got the power for free. We want more power. Because when anything's for free, then you want more because there's no impedance anymore. Well, all of a sudden, the Earth starts to slow down. Then what kind of trouble are we in? So these are things that have to be taken into consideration.
It needs to be a reciprocal regenerative cycle, give and take.
Yeah.
Could I add something?
Please.
Go ahead.
It's my understanding that Tesla said that there's an insulating fluid between what he called radiant matter, that he called what we call electrons. His ideas on atomic theory were completely different than what we have adopted. And
everybody's theories at Tesla time was completely different than what we've adopted, because
right.
we've been forced to adopt something that has no meaning, but it's very profitable to the high priests that administer it.
But let me add to that, because it's also my understanding that Tesla found that he could break down that insulating fluid that separates the electrons from each other. And if I could make an analogy, when you flip a switch of large potentials of DC, which killed everybody in the beginning, and Tesla and some of the other people realized that there were larger potentials in that line than when they put in. It would seem to me by what Tesla was saying is that he was very curious about that particular force that he found, and that would be analogous to let's say a wrecking ball taking down a building, right? It takes a lot of energy to keep on pounding away, but Tesla also found that 10-pound weight oscillator could do the same thing, but it could do it much faster. And so I think that's why he created those spark gaps that used as small energy as practicable to create a spark, because he found that he could break down the insulating fluid that separates those electrons by finding the resonance.
No, not really. You're kind of working on a lot of these illusions. I don't know the right word to alluding to Tesla saying this and Tesla's wild theories here and there. It's best to stay away from all that. Otherwise, you'll just end up in a high-speed chase of your own tail. Electrons, and all that's. It's best just to stay away from all that, because it just leads you down the wrong path. It's just a bunch of complexities.
Hey, because
go ahead.
So we're getting up on 2 hours now. We will have to wrap up here in a little bit. Also, because Zoom has a finite amount of space to be able to record these. So anyway, Reginald, I hope that at least answers some of your questions there.
Can we hear some more questions, Aaron? Can we hear?
Yeah, we have two more people that want to three, and if we can make them real quick, fast bullet point Q&A, and then I just want to remind everybody about the forum link to go in there for some ongoing discussion where Eric and hopefully you and anybody else is will be able to chime in. Let's see, Steve Darlington.
Yeah, I'm here. Yeah. So Steve.
Okay. Yeah, go for it.
I'm from Ottawa, Canada area, and my field is in acupuncture primarily. I've been in the healthcare field for 30 years, and so I think that some of the secrets to free energy lie within our bodies, and I look at the Earth as being a body, a living body, and I think that if we can make some sort of look at it that way, we can understand perhaps that just like in our bodies, there's communication. So the Earth probably communicates all around the globe. Like every aspect of it is interconnected, and because I look at it as a living being. I like how you guys are making the connections to nature. I think secrets lie within the nature. I've also done some interesting experiments with what's called orgone energy, and I make what I call chakra actuators. So the human body, I'm a dowser as well. So we have chakras on the body, and we're pulling in energy 24/7, which is fascinating. I'm not sure exactly what it entails. I know it entails light, but we're pulling it in and we're utilizing it. And
Steve, I would just add that this is very much how we are on the basis of exploring the natural world. So it's very in tune with what you're saying. I mean, of course the planet is a living being. It's called the planetary being.
Right.
Its physical body is called the Earth, but it is actually an intelligent being, which has a very high level of awareness, far beyond ours. And we are all connected in the one, what's called the one life, the web of life.
Right.
So when we talk about doing regenerative experiments, attaching things to the wheel work of nature and all those kinds of things, that is the kind of synchronicity that we are striving to accomplish with these experiments. And that's the only way, actually, that I've discovered that it's really possible to do those kinds of experiments in a life-supportive, inclusive fashion. Because the experiments don't work otherwise. You cannot it's not possible to take a piece of apparatus, put it on the bench and say that's going to suck energy out of the ether. It doesn't work that way. It's a regenerative process where you become naturally a part of the flow of energy in the one life. And the planetary being is a part of that. That's what we were really talking about with the earlier, some of the earlier questions from Don about stimulating the Earth. You are actually cooperating intelligently with the Earth in that process. It goes very, very deep. I like the question that you're asking because it actually alludes to a very deep part of the natural order. For me,
well, anyway. I'll be brief, but what I think I'm detecting in my own experiments with the orgone energy is that it can act when it's built correctly. So a crystal has a polarity, a coil has to be wound in a certain way. You have to have your carbon content or the fiberglass resin, the crystal component, and the metal shavings. And that seems to pull this life force energy into it. And you can project it. So it's creating a field. So people report that their hydro bill can be a little bit less. Is it possible that because with electricity, it's not just what's going through the wire, but the field around it, that because you're dealing with a field, you can supplement the field with another device that's kind of hitchhiking. Is that possible?
It's kind of way too abstract. Things got to be narrowed down more than that.
Yeah. Well, just the EMF field around a wire as the current's going through it, if your device is beside it, creating an energetic vortex like a tornado, could it kind of piggyback on that and maybe act like a supplemental power source, reducing your hydro bill?
Well, there's only one way to answer that, Steve, is to do. Yeah. You need to do the experiment. Do the experiment.
Yeah, I do.
Demonstrate it. We can't possibly say. Maybe it can, maybe it can't. But I mean, the thing is to do the experiment and find out.
Yeah, I'll have to do it precisely. But I know that inside the fridge, in the crisper drawer, the food lasts a lot longer. So there's something going on there.
All right, thanks, Steve. We're going to take a couple more questions.
Thank you.
Okay, thanks.
Thank you.
Yeah, thank you, guys. My main question is trying to do a little bit of correlative work with one of the folks that I've been following for many years by the name Nassim Harriman. And Nassim just popped on out with a new paper, talking about the origin of gravity and the origin of mass. And it's absolutely mind-boggling. It's like a 50-page paper. I'll
You got on mute.
Sorry about that. And what he talks about is he talks about various energy densities when you get into the scale of matter. And so he talks about an energy density of the subplonk, which is basically what we could call 0-point energy. Then there's that energy density goes up to the scale of the proton, and then there's another energy density there. Then there's another one that goes to like the size of the atom, which would be like a hydrogen atom. Then it goes into molecules and all the other various things. So at each level, at each boundary, there's what's called a screening. And so the energy density decreases as you get onto the larger organized areas of matter. And so the thing that I'm seeing that I was very intrigued by is you're talking about how your arcing and the various frequency and the voltages that you're using are possibly kind of creating a fracture in the ether that then once you get that correct frequency can actually be kind of a tap. Now, I'm probably using the wrong terminology, but the thing that then comes to my mind is that you're able to kind of dial into one of these other subplanckian, proton, or atomic energy densities, electron energy densities, which then allow a complete flow through of the power going through. So I'm looking at the work that you just demonstrated here as basically being what I would call kind of like an empirical demonstration of how what the basic concepts in the sim is putting forth are actually produced. Now, he's actually going through and trying to produce this stuff as well, but he's not quite at that phase. And it seems like what you're doing comparatively is a lot more probably low budget and more experimental and very practical way to bring forth some of those concepts. And so I just wanted to put that out there. And if that makes sense, I would strongly recommend that you at least go take a look at some of his ideas and see if you can come up with a basic understanding of geometry and frequency on what he's talking about and how it may correlate with what you're doing here.
Yep. No, I mean, thank you for your comments. In some ways, we are taking a very, very practical way of demonstrating how we are trying to experiment and work with the natural order. It would take a very long time for us to discuss why that is the case, because we are really working here with the etheric spectrum. And to go through the etheric, for us to talk about the etheric spectrum, it would take a long time. We would need to do a whole nother discussion just on that, because the etheric spectrum is vast. But yes, in a sense, you could say that we are working at revealing fundamental vibrations within the etheric spectrum and attuning to those vibrations. That is certainly a large part of the work that I'm doing myself, in terms of exploring the natural order, because the etheric spectrum is vast. It is, and that's all the stuff as well that's not in form. I mean, form is just one aspect of we call the electromagnetic spectrum is a reflection of the form of the etheric spectrum, but that's just 1/10 of it. So but this is a vast conversation. We can only just scratch the surface, but I get the feeling for what you're sharing. That is, it is similar to what it is that I'm also working with.
Well,
let me point out something at this point. So,
go ahead. Sorry.
Okay, so the thing is what we're dealing with here has no connection to modern interpretation.
Absolutely.
Electrons, protons, quantum, this and that. No, there isn't any of that here. Everybody's got all these modernistic interpretations and cockeyed ideas, and it just keeps spiraling outwards and outwards and outwards until it's just a cacophony of white noise. The first order of business here is to completely dispense with all post-Einstein thinking, all of it. all of it, every single piece, and go back to the beginning. And that's what we're doing. We're going back to the beginning, not going to come up with a lot of phantasmical, philosophical interpretations or what have you, even though they're fun and all of that, but they just keep spiraling further and further and further outwards until there's nothing that connects to reality anymore. So I'm approaching this thing strictly from an engineering standpoint. Okay, I'm a radio engineer, electrical engineer. My interest in this is primarily communications and electric field studies. The plasma phenomena and the Golden ratio discharges and all that get off into more of an esoteric and spiritual world, which is interesting, but I don't want to submerge myself in it. My concern is how to get the phenomena, control the phenomena, experiment with them. None of this stuff connects to any modern interpretations whatsoever. This guy's book, that guy's theories, all of that. There's no connection anywhere in this line of work.
Okay, and we're going to have to leave it at that, Steve. I'm sorry, but I'm going to have to cut you off. We got time for one more question, and then we're going to have to wrap it up. And I do want to mention, keep an eye out for these Zoom calls. If you go to emediapress.com, there's an Energy Times sign up form there. That's the first place where I put out the announcements for these. I also put them out on Eric's list and Facebook and all these other places. In the next call, I know Griffin has multiple things that he's going to be presenting on, and probably Haka says, and I'm sure Adrian and Eric have other things to.
Yeah, I'll also give a research update on the next one now.
Okay. And then maybe in the next 2 or 3 calls or something, we can do another dedicated one on a topic. Maybe we can go into the golden ratio stuff, because that goes heavy into, geometric form and the ether and. Well, let me
getting into that. I made a presentation called The Power. What was it? The Power of the Ether as related to music and electricity. And that covers the esoteric end of it. So anyone that's interested in the esoteric side of all this, it's deep into that. It gets heavily into the golden ratio and nature, the structure of music, the things that could have been done with music, the ideas that have basically made it so that we don't have any real control over music at all anymore. It's just basically a bunch of grunting and slapping and sickening sounds. Where, at one point in history, it knocked down the walls of Jericho. And that was not done with kilowatt hours. That was done with something else. So
yeah, if anybody wants a copy of that presentation on emediapress.com, in the search bar at the top right, just enter 2 words, power, ether, and you will find, in this particular presentation, will come up. And then there's a video with the music composer over here from Seattle, in a discussion with Eric on some of these concepts of harmonics and music and electricity. Let's see. Let me stop share here. We'll take one final question from Andre, and then we'll go ahead and wrap it up.
It's fine. Yeah. Good. So first of all, I would like to thank Professor Dollard and the team for the extremely unfathomable work that it's been doing for a lot of years. And I'm a 22-year-old student, master's student right now, started studying at the Technical University of Eindhoven in the Netherlands. And but that's not really important. My question would be to Eric. Have you managed to get a hold of the original Steinmetz papers on the law of hysteresis papers? Because if not, I can provide it to you. I have access to the IEEE databases, and if you would like to have the papers anytime, I can send them to Griffin or to Aaron.
I pretty much have gone through all those and way back. So all that, I pretty much have all of that stuff in one form or another. His books, Theory and Calculation of Alternating Current Phenomena, pretty much are built out of all of those papers and what have you. But there are other papers that I've run across that people don't even know about. And right now, the 3rd volume of my Heaviside book deals with what I learned from one of those papers in particular, which is absolutely stunning, because all these physicists and all these bright ideas and all these quantum theories and all the rest of this gobbledygook, there's still nothing that's hardcore engineering formulation of how much force is exerted on two conductors in a power line when current and voltage is applied to it. It's never given. All you get is a flurry of abstract mathematics and Latin muttering and what have you, and no answer.
I see this every day.
But nevertheless, Steinmetz wrote a paper which basically just completely disappeared on the exact calculation of the forces between the conductors for magnetism. I managed, with the help of a PhD mathematician that I write back and forth with, to convert that into electrostatic units for the electrostatic field. It is so simple and basic of what Steinmetz produced. I have an excellent engineering library. I'd say the quantity of books is 1,000 pounds. And there is nothing in there, and all my experience in electrical engineering, everything I've gone through, that tells you the engineering formulation for the force between two conductors in a power line. And here Steinmetz just lays it out in the most basic format with simple algebra. And you know what they did to him? First of all, in the comment section, the naysayers, which is Karapetov and Pupin, just completely lambasted him for not using physics and, and all their endeared equations, which don't tell you a damn thing. And then what they did is they munged up all the equations so that you couldn't figure out what he was saying. And it took me 3 or 4 months. I almost took the entire set of notes and everything and flung them out the window of my car. It was so frustrating to try to undo the damage they did. And I accomplished that. So this is the beauty of Steinmetz. Steinmetz is like the Prometheus that stole the fire from the gods. And boy, did the gods hate his guts for it.
Yeah, thank you so much. Yeah, I'm facing the calculus things and the integrals, never-ending sea of integrals every day. That's a normal life for a student.
Most of that engineering curriculum stuff is all it is just Heaviside called it useless brain torturing.
Yeah, it's kind of like
somebody like Oliver Heaviside that didn't even graduate from high school could shake the very foundations of electromagnetism, relativity, the whole thing. How could somebody like Faraday that was completely uneducated come up with one of the most important electrical theorems ever in the entire human, history? If you want to learn about electricity, don't go to university.
All right.
You'd be better off becoming a lineman or an industrial electrician, or don't go to university.
I just wanted to ask. It was like a naive question.
In other words, also make sure there's an experiential part. In other words, practical. There's practical work involved, because then you can really get down into exploring the phenomena.
I understand. Okay. Yeah. Thank you so much.
Because then you can taste it and smell it. It's real.
Yeah, and it bites sometimes.
Oh, it bites hard.
Okay, well, I'm gonna just show a couple websites here again real quick. I want to show that on Eric's page again. Actually, let me put Adrian's link up here real quick to show that am-innovations.com. So this is Adrian's website. There's a lot of stuff in there. There's also a PayPal support link, and these go to the experiments that he's showcasing and highlighting on his website. A lot of stuff in here is related to pretty much everything we just talked about. And then also, again, Eric's official website is for EPD Laboratories Inc. is ericpdollar.com. Please go to the donate link. Anything that you can contribute is you can see is going to this exact kind of work in furthering the science of electricity. You can donate by PayPal or send a check or money order. And then on emediapress.com, any of these presentations, you can kind of go through and just search some of these buzzwords, and you'll find these. The Colorado Springs one, if you just type in Colorado, that'll take you right to the page. or at least a link, right? You just scroll down and you can click on the this DVD cover graphic, and that'll take you to the presentation. And if you scroll down, there's the free YouTube video on the part 2 that Adrian did a slideshow on. And then let's see, make sure to go to energeticforum.com. In the top right will be a login or sign up link. It's free to join. I'm going to be doing some updates in here. If you don't get a like a confirmation link, it's been a while since I've been active in one of my own forums here. Is that I'll email out instructions or a website, or I mean an email that you can email to request that we activate your membership in case there's a problem with it automatically activating. But anyway, in here, if you just scroll, go to the homepage, click on the logo, Energetic Forum. These are like the last 20 topics or whatever, and you'll see Colorado Springs. Let's see, I know I just saw it somewhere in here. Okay, it's a second post right here. And these are all the main links, and I'll put a copy of the Zoom call right here on post number 3. Again, Eric was able to post on his own. So if you have any comments, questions, you need support in doing your own Colorado Springs replica, post it in here, and this will be an ongoing support forum. And I think that's about it. Any final words, Adrian or Eric? Oh, when do you want to do this again? Maybe in another 4 weeks or so, or
yeah, in a month
or sooner.
1, 2, 3, 10.
3 weeks. Every 3 weeks.
I would say once a month.
Yeah.
Well, 3 weeks would be February 3rd. No, 10th, I think. 4 weeks would be the 17th. So I'll just email out a schedule sometime soon.
Sounds good.
About the 17th or so of February. Okay.
So I do have a few final things to say about
go for it.
We're working on. So Griffin and I are right now, we're in the process, amongst thousands of other things, of getting up to the 400 watt level for the Colorado Springs apparatus to be connected to the ground terminal here. This is a real ground. It's not something that's available to a lot of people. There's 2 like 20,000 gallon tanks filled with water buried in the ground outside the building, and we do have an absolute ground connection. I think Hakase's YouTube video is pretty clear in very short, concise terms of how that's set up. So, and then Adrian and I are starting to head in the direction of a fully developed 20 kilowatt transmitter using a push-pull pair of the Rusky tubes. That will be an absolute stunning piece of equipment.
Yep.
It'll be very adaptable, and I don't know yet. It's still primordial, and it's kind of hard, working across. I got letters to send to you that I've been delayed. A lot of preliminary material.
Good.
And so
there's no rush. We'll do it step at a time.
I'm considering that for your frequency range, which seems to be between 2 and 3 megacycles per second.
Yep.
And not the Colorado Springs, but
yes, that will be better.
As far as the Colorado Springs unit goes, I have a 5,000 watt AM radio transmitter sitting 15 feet away from me, ready to go for that as soon as the 3-phase power is hooked up. So I don't have to build any of that here. Okay. So that will produce 20 kW PEP. I don't know if the coil can actually handle that much or not, but it does have the transmitter.
There's only one way to find out.
Well, I don't want to destroy it, but at any rate, if we took the thing up to the level we did and it's working out okay, then I think so. That's a big process. I've got to get conduit and wire. It's a lot of money. It's probably another $15,000 of work on the building here. But I do have a matched pair of AM radio transmitters, and one of them is got a crystal in it that's the same as the Colorado Springs coil frequency, waiting. And Griffin has the Navy variable master oscillator, which will connect to the AM radio transmitters, and it has an accuracy that keeps this operation within the guidelines insisted upon by the Federal Communications Commission as far as stability and spurious transients. So he's got to get that up to the 5-watt level, which it could plug into the AM transmitter. But for his use, for his Alexanderson coils, we're going to get it up to the 400-watt level. And that unit will be what drives the 4-400s and then the G, what are they? The
U5B.
Yeah, those. So basically you're working from the output towards the input, and Griffin is working the input towards the output.
And we meet in the middle.
Right.
That's a true intelligent cooperation, Griffin.
Yeah. Is Griffin there?
Yeah, he's just there.
Okay. I don't see him.
Yeah, but nonetheless, this amplifier setup that will work in conjunction with this Navy signal oscillator, that's a project that's in the makings currently. So that'll definitely unveil some interesting information, especially with the scale model Alexanderson coil, which I had presented on in the previous live call, since it is a rather interesting configuration and hasn't necessarily been investigated in great depth at the present.
Okay.
So I guess that wraps it up.
I think so. So since this call has been really appropriate, I'm not going to edit it. I'm going to slap a title screen on and subtitles, and then we'll call it good. So that'll be on YouTube. I'll put a blog post in, and then I'll embed that as post number 3 on the Colorado Springs discussion thread in energetic forum. So you got the main presentation, the part 2, this Zoom call, and then the conversation can continue. So anyway, thanks everybody for your participation in the call. Anything you can do to help out with donations with the EPD labs would be greatly appreciated. And you can see that it definitely goes to supporting this kind of work. And we'll see you on the next call.
Thank you, Aaron.
Okay. Thank you. Take care, everybody.
Okay. Bye.
Bye-bye.